Chapter 3, Section 2, Linear Functions. This is Part 1. Tomorrow we'll get Part 2. Like I said, tomorrow we'll get Part 2 of these notes. I wanted to break it up into two different parts. So today was Part 1. What do you think of when you hear the word linear? Line. So what do you think the graphs of linear functions create? A line, right? Pretty straightforward, hopefully. So that's what we're talking about today. Mainly identifying linear functions from a graph, from a table of values, and from an equation. A linear equation in two variables, x and y, is an equation that can be written in the form y equals mx plus b, where m and b are constants. Does anyone recognize that form of a linear equation?
No.
Yes.
Wait, yes I did.
Do we recognize that form of a linear equation?
Yes.
Do we remember what form that's called? Yeah, slope-intercept form, right? So, if I can write an equation in that form, I know it's a linear function. Okay? M and b are just constants, they're numbers. So it is y equals some number times x plus or minus some other number. Okay? The graph of a linear function, like we already said, is a line. Likewise, a linear function is a function whose graph is a non-vertical line. Because if we have a vertical line, is that a function?
No,
Why not?
because there have to be like a different y value for the x value.
Right. My x values repeat, right? It doesn't pass the vertical line test, does it? So it's still a line, but it's not a linear function. Can't call it a function. Okay? So a linear function is a function whose graph is a non-vertical line. Any other type of line is a linear function. Vertical, except for a vertical line. Right? A linear function has a constant rate of change. Does anyone know another word for rate of change? Starts with an S.
Slope?
Slope. Another word for rate of change is slope. So a linear function has a constant rate of change, a constant slope. That means to get from one point to the next, I'm doing rise over run. And then to get from that point to the next point, I've got the same rise over run. So between all my points, I have the same rise over run each time. Okay, it's increasing or decreasing by the same thing each time. A linear function has a constant rate of change and can be represented by a linear equation in two variables. A non-linear function does not have a constant rate of change, so its graph is not a line. So, if I have a graph and it's a line, it's linear. If I have a graph and it's like a curve, it's not a line, is it? So that'd be called non-linear. Does that make sense? This means yes. This means no. Does that make sense? If the graph is a line, it's linear. That makes sense. If a graph is not a line, like a curve or something, it's non-linear. Does that make sense? Okay, perfect. If I can write an equation in that form, y equals mx plus b, it's linear. If I cannot write it in that form, it's non-linear. If something has a constant rate of change, it's linear. If it does not have a constant rate of change, it's non-linear. Any questions on any of this information we've been given on this slide? Okay, can I go ahead and move on? Okay, example 1. Identifying linear functions using graphs. So it gives us two graphs here, A and B. It says, does the graph represent a linear or non-linear function? And it does want you to explain why it's linear if it's linear, or why it's not linear if it's not non-linear. Okay? So letter A. Here's our graph. Raise your hand if you can tell me linear or non-linear.
Non-linear.
Non-linear. Why is it non-linear?
It's not a straight line.
It's not a line, right? So I would say non-linear.
You can actually spell it.
Yep. Go ahead and spell it out. It's not that bad. Nonlinear. And what was your explanation? It's not a line. That works. It is not a line. That explanation would work because I'm looking at the graph. Okay? Let's talk about rate of change here. So I have an ordered pair here, here, and here. Rate of change, rise over run, slope, right? To get from this point at the bottom of my curve to this next point, how far am I going up? 1. How far am I going over? 1. So 1 over 1. What's 1 divided by 1? 1. So my slope between these 2 points is 1. Okay? Now let's go from that second point up to our third point. How far am I going up? 3. How far am I going right? 1. So 3 over 1, what's the slope there? 3. Is that a constant rate of change? Is it the same between these 2 points as it is between these 2 points? No. So does it have a constant rate of change? No. That could be another explanation on this problem. It does not have a constant rate of change. Either of those explanations would work. You do not have to put both of them. Okay? Any questions on letter A? Why it's non-linear? We okay with that? Okay, letter B. Bless you. Raise your hand if you can help tell me if this is linear or non-linear and why or why not. Linear, why is it linear?
Because it's a straight line.
Linear? Because it is a line. Everyone okay with that one? Now let's look at the rate of change here. We got an ordered pair here, here, and here. Let's go from the bottom point to the middle point. How far am I rising? 2. How far am I running? 1. So that's 2 over 1. What's 2 divided by 1? 2. Now let's go from the middle point to the third point. How far am I rising? 2. How far am I running? 1. 2 over 1 is? 2. Do I have a constant rate of change there? Yeah, I'm increasing by the same thing each time to get to the next point, right? So that could be another explanation. It has a constant rate of change. Questions on example 1, A or B? We okay identifying a graph as linear or nonlinear and explaining why or why not? All right. Can I move on? Sweet. I now have a table of values, and it wants me to tell you whether the table represents a linear or nonlinear function and explain. Any ideas on how I'm going to do this?
Yes. So A is linear
Why is it linear?
because it goes up 3 times. 3 plus 3 is 6. 6 plus 3 is 9. It goes up by 3 each time.
The x values? Do I have to check the y values at all or no?
Yes.
Yeah.
Yes, I do. So, we are on the correct path
Minus
on
sixes.
determining if it's linear or nonlinear. I've got to check the rate of change since I have a table of values. Do I have the graph right now? No. So I can't just say, oh, it's linear because it's a line. Can I? Or it's nonlinear because it's not a line. So yeah, we don't see the graph, so I can't say, hey, it's linear because it's a line, or hey, it's nonlinear because it's not a line, can I? I've got to actually look at my rate of change here. My rate of change is my change in y over my change in x. So I've got to make sure my x values and my y values are both increasing or decreasing by the same thing each time. Okay? My x values don't have to match my y values, but it's got to be constant for the y values, it's got to be constant for the x values. So like Willie said, to get from 3 to 6, what am I doing?
Going up 3.
Adding 3. 6 to 9.
Going up 3.
Adding 3. 9 to 12. Adding 3. So my x values are increasing at a constant rate, correct?
So, if it's like out of rate, like say like for B, it's not.
Let's wait till we get to B. Okay? But I cannot just check my x values because rate of change deals with x and y values. Okay, so I've got to check my y values as well. To get from 36 to 30, what am I doing? Subtract 6. 30 to 24. Minus 6. 24 to 18.
Minus
Minus 6. Is that increasing or decreasing at a constant rate? Yeah. It's going at a constant rate though, right? So my rate of change here is constantly negative 6 over 3, which is negative 2. Right? So I've got a constant rate of change here, so would we say it's linear or nonlinear? Linear? Do you think I can use the explanation because it's a line?
no.
No, because I'm not looking at the graph, am I? It will create a line, but I've not seen that yet. My explanation needs to be based on the information that I'm given.
It's linear because of constant rate of change.
Very good. It's linear because it has a constant rate of change. Very good. Does that make sense for letter A? We good with that one? Can I move to letter B? Okay, we're going to approach it the exact same way. I'm going to check my x values, and I'm also going to check my y values. How do I get from 1 to 3? Add 2. 3 to 5. Add 2, and 5 to 7. Add 2. So right now, it's looking pretty good for it being linear, but I cannot just base that on the x values, can I? Got to check the y values as well. 2 to 9, what am I doing?
7,
Add 7. 9 to 20.
11,
Add 11.
15.
20 to 35. Add 15. So my x values are increasing at a constant rate, but are my y values?
No.
No. So is this linear or nonlinear? Nonlinear. And what's my explanation here?
It doesn't have a constant rate of change.
It does not have a constant rate of change. Are we okay with that? We're okay identifying a graph as linear, nonlinear, and explaining why? We're okay identifying a table of values as linear or nonlinear and explaining why. Okay, can I move on?
Yeah.
Someone say no? Okay, I'm giving you a little bit of time.
Point, that's rude. Okay, you can move on.
We good?
Yeah.
All right. Now, let's get some equations and determine if these are linear or nonlinear. This is not one big equation. Don't panic. I've got an equation here, 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 and here. 6 different equations. Okay? Any ideas how we're going to tell if these are linear or nonlinear based on that first paragraph that we looked at the beginning of the notes? No, not plug in Y.
Plug it in with slope intercept form?
Yeah. Slope-intercept form, right? If I can write these equations in that form, that exact form, y equals mx plus b, then I know it's linear. Does that make sense? So what variable is by itself in slope-intercept form?
B.
No. Y, right? Y is by itself on one side of the equation. So, I'm going to try to get y by itself on all these equations and see if they're in the slope-intercept form. Okay? So I've got y equals 3.8. Someone raise your hand and help me out here. This one's kind of tricky.
Put a plus in between the 3 and 8.
No, I've got a decimal there. Anyone help me out? Tell me if this is linear or nonlinear. Yep. Why do you say it's linear?
Because of the point
The 3.8. How is this in slope-intercept form?
go.
I agree, this is linear. And this is how I can make it look more like slope-intercept form. By putting 0x in there. What's 0 times x?
0.
0. That's why it's not written in there. Okay? So I just have y equals 3.8 here. So the slope of this line is just 0. It's going to just be a horizontal line. Okay? But this is in the form, slope-intercept form, right? Y equals mx plus b. M is 0. B is 3.8. There's slope-intercept form. Questions on that one? Yep. Say it again.
I don't get how this is laid out.
So my slope is just 0 here because 0 times anything is 0. So no matter what I plug in for x, it's always just going to be 0 right there. So I'm always just going to get 3.8 for y. That's why it's just y equals 3.8. So like I said, the slope of this line is 0. It's a flat horizontal line.
What about other stuff?
Say it again.
They're like the other stuff like.
On this first one.
There are other.
Are you talking about these?
Other variables. He's asking what happened to A and B. Right?
Oh, m and b are just constants. Means they're just numbers. Okay? So m here is 0. B here is 3.8. Y and x will always stay as y and x. Does that make sense? I see where the confusion was there. Okay? So this one is linear. And my explanation would be it's linear because I can write it in the form y equals mx plus b. Okay? Now I have y equals square root of x. Is y by itself?
Yes.
Yes. Is there any simplifying I could do here, taking the square root of x or anything like that? No. So is this in the form y equals mx plus b? It is not, is it? In my slope-intercept form, does x have a radical on it? No. So I don't want a radical on x, do I? So there's no way I could get rid of that and get y by itself to look like this. So this one would be what?
Non-linear.
Non-linear. And it'd be because I cannot write it in the form y equals mx plus b. Questions on that second one? Yep.
You say you can't get rid of the radical.
You could get rid of it. If we did get rid of it, we'd have to square.
Yeah, I was about to say that.
But if I square that side, I've got to square this side. So I get y squared equals x. Is y squared in my slope-intercept form?
It's not.
It's not. You were just confused by me saying we can't.
Yeah.
I got you. We can, but y is already by itself, so that doesn't help me get it in the slope-intercept form. Okay? Questions on the second one? Okay, the third one. Y equals 3 to the power of x. It's not 3 times x, that's 3 raised to the power of x. Okay? What do we think here? Is y by itself already? Yeah, y is by itself. So as of right now, is it in this form?
Yeah.
It is? Remember, it's not 3 times x, it's 3 raised to the power of x. This is m times x. Okay. Oh yeah. Y is by itself, right? But is it in the form slope-intercept form? It is not, is it? Is there any way I could get it to that form?
Yeah.
There is? What could I do?
Am I right?
Oh,
Okay.
square root of that.
I could take the xth root, but I'd have to do it to both sides. So I'd get the xth root of y equals 3. And is that in slope-intercept form? No. So there's nothing I could do here to get it into this form, so this one is non-linear. Any questions there? Can I erase these down here? Give myself some more room. Okay, now we've got y equals 2 over x. Y equals 2 over x. I've got x in the denominator here. Let's try to get x out of the denominator. How would I do that? Yeah, multiply by x on both sides. That'd give me x, y equals 2. Is that looking more like slope-intercept form? No, because if I was trying to get y by itself, I just have to divide by x on both sides. And that just takes me back to where I originally was. So what do we think? Linear, nonlinear? Nonlinear. We okay with that one? Okay. Y equals 6 times x minus 1. Any ideas here? What? Distribute, yeah, I can distribute here. 6 times x? 6x. 6 times negative 1? Negative 6. Have I done all the simplifying I can do?
Yes.
Yeah, is y by itself?
Yes.
So is this in slope-intercept form?
Yes.
Yeah, it is, isn't it? So linear or nonlinear? Linear. Once again, my explanation would be because I can write it in the form y equals mx plus b.
Well, does it have to be plus? No, it can be minus.
It can be minus, and here's why. If I were to write it exactly like slope-intercept form, it'd be like that, which is the same exact thing. If I add a negative, it's the same thing as subtracting. So it's fine if it is like that. Okay? Questions on that one still? Okay, my last one. X squared minus y equals 0. All these other ones, y was already by itself, right? Is y by itself here? Okay, now let's get y by itself, see what happens. What would be my first step getting y by itself?
Square,
How would I get rid of that x squared with it? If it's a positive x
plus
squared.
x squared.
Not plus x squared. If it's a positive x squared,
Oh,
subtract x squared. Give me negative y equals negative x squared. Because 0 minus x squared would just be negative x squared. How would I get y by itself? Divide by negative 1. So y would give me x squared. Y is now by itself, correct? Got y equals x squared. Is my x squared in slope-intercept form?
no,
No. So is there any way I can get this into slope-intercept form?
no,
No, so this one is
nonlinear.
nonlinear. Once again, for all the nonlinear ones, the explanation is I cannot write it in the form y equals mx plus b. For the linear ones, it's I can write it in the form y equals mx plus b.
Are we not allowed to do NL? Like shorter?
I'd probably know what you mean. But does anyone have any questions about identifying whether an equation is linear or nonlinear? Any questions on that? We good? Let me give you one more real quick. Say I gave you y equals negative 3x.
Nonlinear?
Why do you say nonlinear?
Because there's no plus b.
There's no plus b?
X.
Kind of thing about what we did with y equals 3.8.
It would be
Oh, wait,
0x
it would be
plus.
linear.
Well, no, it would be 0x minus 3x,
Yeah.
right?
It says
So
linear.
Y equals, yeah, negative 3 plus 0?
Oh.
That's how I could write it in slope-intercept form. My b value is just 0 here.
Maybe zero.
It's not written there, so I know my y-intercept where it's crossing the y-axis is just 0. Because anything plus 0 is just going to be itself, right? So when we write an equation, we really don't usually write redundant information. So if I'm adding 0 to something, that's kind of redundant because anything plus 0 is going to be itself, right?
Yeah.
So that's why it's written without the plus 0. Does that make sense?
Yeah.
Okay. Any other questions? Am I good to move on? Here you go. Here's your assignment. Page 119 through 120, numbers 5 through 26 all. This will be due Wednesday, 26th. On Canvas. Make sure you get this written down. Make sure you get the correct heading at the top of your paper. Name, date, period, assignment in the upper right-hand corner. Are there any questions about the notes before I end the recording?